2 to the power 7, which you can see here. And now those of you who have joined us now, Assalamu alaikum, we are working on chapter number 1. Like we'll try to take two things together so that we are like sometimes we're going to study one thing and then the next unit we're going to study the next topic just to keep you all active. Is that a better option? Yes, children, is that okay? That we try to keep two things simultaneously, that you are able to keep interest. Is that strategy? I hope that will help you. Now moving further, we have this denary number, which was 107. This is called denary because this is something that we humans comprehend, we humans understand. And the next number system is what computers understand, that is called binary. So in order to convert, what we did, we worked on a byte, and this byte has 8 bits. And we started with the right-hand side, that was 2 to the power 0, 1, 2, 3, 4, to the power 4, to the power 5, to the power 6, and 2 to the power 7. And when I looked at the answer, I hope that you all had answered me that day. Immediately you answered that 2 to the power 0 is always equal to 1. So this is why you can see that 1 is written here, then 2, then 4, 8, 16, 32, 64, 128. And likewise, the values increase. Like you can, if I have the next bit active, it means it will be 2 to the power 8. That means 256. I hope that this is something that we all can very quickly recap. And in order to find out the answer, what we will do is we will have to see from this side that will this bit be turned on. My answer is a no, because it's 128, which is bigger than 107, which is bigger. That is why I'm going to put a 0 here, means I'm not using it. 0 means not used and 1 means being used. And then if I move further, I'll take 64. And then I'll look at it, will 32 be there? Then my answer is 64 and 32 makes 96. And 96 is less than 107. That is why I have placed a 1 in both the positions, which are 64 and 32, and that makes up 96. Now what I did, I subtracted 107, like what I did, I subtracted 96 from 107, and what I got was 11. Then I'll look at the rest of the values, and then I'll find out, no, binary numbers are understood by computers. They are meant to understand binary, and we humans understand the this denary. Denary is for us and binary is for the computer. Shikari, is that clear? I hope that this is now understandable to everyone. Now moving further, any query, any further query? Like I just saw the message, and I hope that your queries are answered now. Now moving further, we are left with 11. So which bits should be turned on to get 11? I guess this is very simple. I will have 8 and 2 and 1. So 8 and 2 is 10, and 10 plus 1 is 11. In this manner, I will get 8, 2 and 1, 11. And this is going to complete my bit pattern. Whichever are supposed to be turned on, I placed a 1 there. Whichever was supposed to be off, I placed excuse me, a 0 there. Any further query? May I move ahead? Yes, the ones who are not there, is that clear to them as well? I sure anyone else? Yes. Are you all comfortable?
Yes, miss.
Okay, may I move further? Now let's move on to a very quick showing of the method 2, and which is simply division by 2. Like we will not take any other number except for 2. This is what you need to remember. It will be only by 2 because we are working on binary. Remember, we are working on binary. And for binary, we need to have the division by 2. So this is another method present in your book as well. But being a teacher myself, I would suggest you that better understand method number 1. But if you want, I can explain you method number 2. This is simple division by 2. And what you do is you write the quotient here, and then you write the remainder here. Then what you got, 2 5s are 10, then no remainder, then 2 3s are 6, 1 remainder. You wrote the remainder after writing down the quotient here, 53. Then 2 2s are 4, passed on the remainder, it makes 2 6s are 12, remainder 1, 13 2s are 26, remainder 0, 2 6s are 12, remainder 1, 2 3s are 6, remainder 0, 2 1s are 2, remainder 1. And in this manner, But there is a problem that we need to understand, that when I am putting up the answer, this is something that may create sometimes problems for me. From where should I write? Although I said start from this side, from the left hand side, but then a problem comes, where should be my next, by my first binary bit value? You can see how many bits are mentioned here: 1, 2, 3, 4, 5, 6, 7. So what you need to do is, you need to start writing down from this, from the seventh position or from the eighth position. So you can see the answer is going to be the same as was there earlier, but sometimes it may create problems for some students. That is why I always suggest that you better move on to the first method. Keep yourselves to the first method, which is not very difficult. With practice, you will be able to understand, and I'll be posting, inshallah, some practice questions for you people as well. Is that clear? Yes, Arun, is that clear? Yes or no? May I move ahead?
Yes, miss.
Okay.
Yes,
So
miss, clear.
up to you whether you want to work with method 2 or method 1. They both are appropriate. They both are understandable. Okay, ji? Now moving to this activity. Can anyone, can we do it quickly, very quickly? 86. But before that, I want you to help me out with 15, 1, 5. So what will be the binary value for 15, 1, 5? Come on, quick. I want quick response. What will be the binary value for 15? Ji beta.
Miss, it will be 0, 0, 0, 0 and 1, 1, 1, 1.
Okay, that's wonderful. So may I know who was the one who spoke right now? Who answered? Was it you, Zainab?
Zainab Fatma.
Okay, along
Yes,
with
ma'am.
Zainab. By the way, Tehreem, Zainab, Zahra, Zimal spoke once, and then Barira. What about the other children? Mashallah, you are quite good. So where are your voices? I can't hear you. Where are your answers? I can't see your messages. So are you all comfortable? Are you able to understand? Any problem faced by anyone? Ji beta, any problem
No,
you're
miss.
facing?
It's all clear.
Amara, thank you. But along with that, I want you people to answer as well. So who is going to
Miss, we
answer?
did these questions in the first class.
But someone said that we didn't understand. So if you're
Okay,
comfortable,
miss.
I'll move on to the next one. Okay, now thank you very much, Barira. But if this is, yes, I'll definitely let you know, Aisha. I'll definitely let you know. Like definitely, if there are certain things that you need to do, I'll definitely let you know. Okay, now if anyone asks you, okay, what is the maximum value that can come in a byte? So what will you reply? Quick response I want.
Miss, 255.
Exactly. So these kind of questions you should be aware of. Okay, how many? What will be the maximum value in a byte? What will be the maximum value in a nibble? Yes. Are you aware of the term nibble? Did we talk about nibble and did we talk about word? Nibble?
Yes, miss.
What is a nibble? Yes.
Miss, please repeat what nibble is.
What is nibble? Nibble. Nibble. Like along with teaching you.
Miss, it is
Did we-
made up of 2 or more bytes.
that was a word, Barira. Thank you very much, Barira. But beta, that was a word. When I say nibble, I'm writing it down on the chat windows that you all can actually note it down. This nibble is basically a combination of 4 bits. Okay, this is what we need to know. And a byte is a combination of 8 bits and nibble is 4 bits. So this is, and what is the maximum value of a nibble? What can come maximum in a nibble? Yes. 4 bits. If you just add them up quickly, what is the answer? Yes, please. I want the answer, please, to come from your end.
It's 15.
Exactly. So please note it down as well that you need to remember. Did we do this binary to denary conversion as well? Yes, ma'am. Maybe quickly
Yes,
recall.
miss.
Are you all comfortable?
Yes, miss.
Okay, now still let me recap. For those who are not able to recall, it is for them. This is the conversion that is meant. Okay, now children, one more thing. Although this presentation is working on 8 bits, but you do have a question that deals with 16 bits. You do have questions which are dealing with 12 bits. So you need to be well versed with because if you don't have the book, I'll be trying to share the screenshots of those books that you can at least start your work and you can do something. So this is what I will be doing with you, inshallah, today. after the class ends. After my classes end, I'll be trying to share with you, inshallah, today what you need to do. But you need to be aware of how will I be working on at 12 bits. So if I say 12 bits, after 2 to the power 7, it will be 2 to the power 8. Okay, word, basically a word is a combination of 2 or more bytes. So nibble is 4 bits and word is 2 or more bytes. Okay? So along with bytes and bits, you better wrote down 2 more terminologies, which are nibble, which is 4 bits, and then we have another one that is a word, which is 2 or more bytes. So if you get a question like the way we are actually getting such questions in our P1, paper 1, and I saw one question that was dealing with nibble and a word, and they had given it in the form of fill in the blanks, and students were supposed to pick up the values and then put them in the right position. So that is why I thought it better to tell you right now that you are comfortable with the terminologies. Now, moving further, I hope that this is now clear. What you need to do, you need to understand and remember the positions and the values, because then you will not be getting the one that I wrote. You have to write it down yourselves. And for that, you need to remember that it's 1, 2, 4, 8, 16, 32, 64, 128. Definitely you are aware of 1, 2, 4, 8, 16, 32, 64, 128, and whichever bits are turned on, you are going to place the value and then add them up, and then you are simply going to get the answer. And this is a very simple method of finding out the conversion from binary to denary. So this one is very easy. Anyone facing any problem, so please ask now before I proceed to the next conversion. Yes, Sharon, anyone is facing any problem with this? No, nothing means what should I assume?
Miss.
A thumbs up if you have understood. Yes, a thumbs up. Only 1, 2, 3. If you have understood, then a thumbs up so that I will be satisfied that you have understood it well. Yes, children. A thumbs up or a thumbs down so that I will be in a position to know that we can work further, we can move further. Now moving on to the next task that we need to work on, and that is this is the activity you will be showing. Okay. Now there's one more thing that we need to know, and that is my hexadecimal. The method is the same. Whatever I told you, the method is the same. And what we do is, okay, let me show you with the help of an example. If, for example, I have the same question and I was asked to convert it from denary to hexadecimal, 107. So what will I do here? I will first of all do one thing, and that is I'll start dividing it by 16. So this is what you need to remember, that I'll not be dividing it by 2, I'll be dividing it by 16. Is that clear? Yes or no? So you will be doing this conversion in this manner, that you will be dividing it by 16. Am I clear? Yes or no, children?
Miss, could
Yes,
you please
miss.
re-explain hexadecimal?
Yes,
I
hexadecimal is
don't
basically,
understand it.
okay, no problem. Hexadecimal is a number system that deals with basically total 16 values. And these 16 values are actually starting from, let me share the points. And then I'll talk about this is hexadecimal. Total values are 16, and they are made up of values from 0 to 9. And the next is A, B, C, D, E, F, which is actually 10, 11, 12, 13, 14, 15, 16. And this is why I asked you earlier, are you aware of this thing or not? This is why, like, my first question in the beginning was, ki aapko pata hai iske bare mein? So this is what is basically my 16 decimal, hexadecimal or 16. And we are going to talk about the uses of these hexadecimal as well. Like, we'll talk about the uses as well. Now, what is the simple method? Simple method is, please remember that the simple method is we have to convert a decimal number, a denary number to binary, or denary number to hexadecimal by divisions. And divisions are by 16. Okay? So please remember the rule. The rule is very simple. The rule is the same, that we perform division by 6, dividing it by 16. Okay, ji, ye aapko yaad rakhna hai. And then we have, let me open the other presentation through which I will be able to explain you the division by 16 as well. But what will I do? Let me open the next presentation and okay. But can you start division by 16? Till the time I'm opening this presentation, the next one for you people, can you start working on the same that you are going to do the division by 16 and you will have the, yes, can you keep on doing 16, 107 divided by 16. But then what you will be doing is you will be writing down the answers in this manner कि आपने लिखना है क्या? You'll have to write down if the remainder is 10, you will say it's going to be 10 is going to be written as A, then we have 11, which is going to be written as B. Likewise, 12, the remainder is 12. I'll write C. This is what you need to work on. So can you work on 107? Let's see who is going to get the first answer first. Yes, children. May I know, please? May I know the answer, please, coming from your end? Any one of you can do it? Yes, children. Just give me a minute that I am able to open the presentation for you people, and then you can see it for yourselves, and I'll be definitely posting that presentation as well. Okay, this is another thing that I really have to share with you later, but not right now. Yes, did you get the answer? Gee, did you get the answer, children?
Miss, it is unclear for me. Can you explain it?
Actually, let me get this for you. Chalein ji, mujhe ek aur chalein ji, let me share another thing with you people. What is unclear? Yes, I know what is unclear. I just talked about, okay, now the one that is shown to you, is this clear? Is this hexadecimal clear? What is hexadecimal? Yes. Is there anyone who has the book right now? Yes, is the book available with anyone? Do you all have
Yes,
the book
miss,
right
I
now?
have.
Okay,
Yes,
can you
miss.
see that we have conversion? Those of you who have the book, that's more than wonderful. If you can see, our book has activity, like page number is 3, where we have converting a binary number, converting to a binary number, converting from denary to binary, and converting from binary to denary. These two topics we have covered. And next we are going to work on hexadecimal. But before that, I need you people to be aware of these terminologies. Ke, agar first like if I say I have 16 participants, or if I have 15 participants, so if I'm saying it in hexadecimal, what will I say? I'll say I have F participants. There are 12 students who have raised their hands. I will say I have C participants who have raised their hands. So is this first thing clear? Yes or no? Then I'll move ahead. Yes. Is this first thing clear?
Yes, miss.
Okay, now I want to move on to the next thing that is dealing with hexadecimal. And for that, I have opened another thing that is even in your book, and that is on page number 7. If you open page number 7, then you can see the same thing as I am showing you right now. The same, something similar to this one. This is what I want you all to remember. Okay, ji? Whenever I'm working now, can you all see my screen now where hexadecimal or hex is written? And a nibble is also written. Can you all see that presentation?
Yes, miss.
Okay. Now pay attention to this. I'll try to explain you. I mean, it's very simple. Just try to assume this as a sort of a, I can see here it says denary, hexadecimal, binary. Page number 7 of your book has a little different placement, but otherwise this thing is the same. So if I work on the first 2 columns, what does it say? Denary is 0 and the same is in hexadecimal. Denary 1 is the same in hexadecimal. So till 9, it's the same in hexadecimal as well as denary. Is that clear? Yes or no? Yes, children. Is this terminology clear what I said? Okay, in denary we have 10 digits which are starting from 0 to 9 and which you can see here. Yes. Are you comfortable with this discussion? Yes, children. Are you all
Yes,
comfortable?
ma'am.
Now,
Yes.
is there anyone who is facing problem with this with these first 2 columns? nahi,
No, miss.
Amna, I'll move to that point later, but right now, since I was opening the next presentation for you people, that's why I was asking you to do it, but I'll do it myself. No worries at all. Okay, Amna? Okay, now let's do it with me slowly and gradually, and then inshallah you will be comfortable. Now, as far as the first two columns are concerned, any ambiguity regarding the first two columns? So please do let me know. G, any query regarding the first two columns?
No, miss.
Okay. Now, if I talk about the value which are starting from 10 here, what we say 10 is treated as what? Is treated as A in hexadecimal. Is my statement clear to everyone? Yes, when I say
Yes,
A,
ma'am.
A is actually 10. Similarly, if we move further, we have B, C, D, E, F, and F is my last. And the same question I asked earlier. I hope that I'm not confusing you at all. And this is going to make the life easier and that you will help you in remembering. We have the last value is 11, 15, which is F. Is this clear? Are these first two columns clear? And then I'll move on to the next column. Any ambiguity in the first two columns? Please,
No, miss.
let me
They are
know.
clear.
Okay, thank you very much. Now moving on to the last column that is dealing with binary. And what is it? And for that, you can refer to this nibble, which says 1, 2, 4, 8. So if I say 0 means nothing is on. So by the way, if I say nothing is on means if I entered a room and we assume these as I have 4 switches in my room and every switch is linked with a certain number of bulbs. Is my explanation clear? Every switch is linked with a certain number of bulbs. Okay? The first switch is linked with 1 bulb, second switch is linked with 2 bulbs, third switch is linked with 4 bulbs, and fourth switch is linked with 8 bulbs. Is this clear? You may have seen certain things happening at the events when you enter with one click only, or the entire area is can say is illuminated, and with one click only the entire area is dark. So you may have seen certain things happening. मतलब एक आप button दबाते हो, 4 lights खुल जाती हैं, whatever, something like that. So assume, just for the purpose of assumption in the beginning. Otherwise, inshallah, after today's class, you'll be comfortable and you can attempt any sort of questions. Yes, may I move ahead? So if I say none of the bulbs are on, so definitely what does it mean? Which switch, how many switches are on? Yes, exactly. You must have seen certain things there because we don't. Exactly. Since when I entered my room or if I entered my classroom, the entire area is dark. So it means all the switches are off. Again, I'm repeating certain things which I did in the previous class, but since previous class was the first class for you people, that's why I am going for a little revision. 0 means off and 1 means on. Like if I'm active, I will say I'm 1. If I'm inactive, I'll say I'm a 0. So that is what we need to remember for our sake. Now, moving further, if I say I have to turn on 1 bulb, so which switch will I turn on? The first one, the second one, the third one, or the fourth one? Yes. I want to turn on 1 bulb. Quick responses, please.
The first one.
The first one, exactly. So I'll turn on the first bulb. I'll turn on the first switch. And this first switch turned on and the rest of the 3 switches are off will make 1 bulb active, 1 bulb on. Is that clear? Yes or no?
Yes.
Okay, now if I move on to 2. Now, if I look at this diagram, this says that 2 is linked with the second switch. So it means that I will turn on this second switch and the rest of the 2 switches are off, and then the result will be this situation, and that will be turning on 2 bulbs. Is that clear? Yes, children, is that clear? Yes. Okay,
Yes.
that's wonderful. If I say 3, so what will 3 be? How will I turn on 3? Like there's no 3 as such, so how will I turn 3?
The first and second switch.
Exactly. That's for the bidder. When you want to work on this binary, I suggest you, for the beginners, just start doing it from here. Just remember that you will be turning on as many switches as the value is. Like although there's no 3, but definitely if I say 2 plus 1, so 2 plus 1 is 3. So I'll turn on the first bulb and the first switch and the second switch, and they will turn on 3 bulbs. Is that making sense? And that is where you can see here, it's 1 1 0 0. The rest of the 2 are off and the first 2 are on. Am I clear, children?
Yes, miss.
Okay. Now, in this manner, can you work yourselves very quickly for 4, 5, 6, 7, and 8? Likewise, I hope that this is now going to make very clear sense to everyone. Yes, children. Because then, if you are saying yes, and then I'll be moving further to the next topic. Yes, can I move ahead? Or do you need time for looking at this? Okay, now if I just again I asked that what is the maximum value for a nibble, and that is what someone said, that I guess it was Barira or Zehra who said that 1111. So that is what you can see here, that for F or 15, it's all the 4 bits turned on. It means the nibble is completely on for the hexadecimal maximum value, that is F. Yes, are you all comfortable? No, because nibble is basically 4 bits, which you can see here. This whole thing is nibbles. You can see this one is 4 bits. This one is 4 bits. This one is 4 bits. I guess that you are comfortable about the terms bytes and bits. This is what we discussed in the previous class. Yes or no? Yes, Sharon. Did we talk about bits and bytes in the previous class? Didn't we talk about bit is the smallest unit of memory and byte is the non-addressable unit of memory, and byte has 8 bits? Yes, can you recall? And this what I yes, children. Did we discuss the terminology byte and bit? Yes or no? If we did, then please do let me know.
We did it, miss.
Yes, we did it. Okay. Now maybe that is why. But byte is basically a combination of 8 bits. What I showed you earlier in the denary to binary conversion, that was dealing with 8 bits, and that was a byte. And when I talk about a nibble, this is 4 bits, which you can see here. Every value that you can see on the screen right now has 4 bits, and they all are actually nibbles. Am I clear? Am I clear to every one of you? Now, any ambiguity regarding any of the value, like if I say 12, okay, now let's do it randomly and then we'll move on to the next thing. Yes, what is 12 actually? If I say 12, there's no 12 as such, but you can see if I turn on 8 and 4, these two switches, it means they will be turning on 12 bulbs. And this is what I have done here. I've turned on the first two bits from the right hand, from the left hand side, and you can see the combination 1100, 0011, whichever is feasible. But I suggest you that you keep one method with you कि जी हमने right से answer करना है और हमने left से answer करना है. So are we comfortable with these conversions? Yes or no?
Yes, miss.
Okay. If you are comfortable, then let me move on to the next conversion, that is binary to hexadecimal. It is very simple. The method is mentioned to you. What you need to do, you have to take the binary number and you have to start dividing the digits into groups of 4, which are going to start from the right hand side. Now, please, we have to remember that this is starting from the right hand side. And for the beginners, I always tell them, okay, just assume, just like math, we do the operations, arithmetic operations from the right hand side. So assume in the same manner that I'm doing it from the right hand side or from the units place, and this is just for the purpose of understanding. And then you will be converting the values into hex values. And the first question is for you people, what will I do? How many bits are here? Are you all comfortable about the method? Which you can see the procedure. You have to take the binary number, divide the digits into make groups of 4, and you have to start from the right hand side, and then you will be writing down the hex value for each value. Is that clear? And then we have the question. Yes, can anyone help me out with the answer? Yes, children. But it's Azan time. Let me be silent for some time, and in the meantime, you can just see that will you be able to do it. Answer is in front of you, and after Azan, I'll try to explain you. If you are able to understand, wonderful. But if you're not, I'll explain you later. Okay, now, Assalamu alaikum. G. Children, were you all able to understand whatever is displayed right now on the screen? Yes. I was silent because of Azan. Now I'm back. This is
I
actually
don't
the...
understand it.
Okay, Zara. I was silent because of the Azan time, but what I said earlier, you can see this is basically which conversion. Now, actually, we have to do 6 conversions. We have done 2, denary to binary, binary to denary, and then we are going to work on hexadecimal. And the one that we are going to do, it's very simple one that deals with, let me tell you, this is basically binary to hexadecimal conversion. I have a binary number. A binary number means a number composed of zeros and ones. Okay? And I am asked to convert this into its equivalent hexadecimal value. And this is the procedure. And I have shown you a question. And what I did, I actually started making pairs of 4 bits. And this is what I did here. You can see I started from the right hand side, and then I have to make 4 bits pattern, which are, okay, now children, we are going to definitely join back for the 5-10 minutes time that we still have. Like still we have 10 minutes, so I'll be making the I'll be starting the class once again. Okay, so you can join as well. Fine. Okay, now what I did, I started making the patterns from the right hand side, and what I got was, it was this thing. Is this first stage clear to everyone? Yes or no? I started just making the pairs, that's all. I just started making the combinations, like 4 bits pattern, but they are all together. Is this first stage clear?
Yes, miss.
Okay.
Yes, miss.
Okay, now what I did next was I started working on the next pair, and which you can see the next pair is this one. By the way, how many bits are there total?